As we promised, in this lecture, we will explore additional ways to improve our chances of reaching the global minimum, rather than getting stuck in a local one. The gradient descent and the stochastic gradient descent are good ways to train our models. We need not change them, we should simply extend them. The simplest extension we should apply is called momentum. What is momentum? An easy way to explain momentum is through a physics analogy. Imagine the gradient descent as rolling a ball down a hill. The faster the ball rolls, the higher is its momentum. A small dip in the grass would not stop the ball. It would rather continue rolling until it has reached a flat surface, out of which it cannot go. The small dip is the local minimum, while the big valley is the global minimum. If there wasn't any momentum, the ball would never reach the desired final destination. It would have rolled with some non-increasing speed and would have stopped in the dip. The momentum accounts for the fact that the ball is actually going downhill. Now, in our gradient descent framework so far, we didn't consider momentum. There is no reason to ignore it. Therefore, we created algorithms that will likely fall into a dip, if there was one, instead of descending to the optimal solution. So, how do we add momentum to the algorithm? The rule so far was Wi equals W minus eta times the gradient of the loss with respect to W. Including momentum, we will consider the speed with which we've been descending so far. For instance, if the ball is rolling fast, the momentum is high. Otherwise, the momentum is low. The best way to find out how fast the ball rolls is to check how fast it rolled a moment ago. That's also the method adopted in machine learning. We add the previous update step to the formula. We want to multiply it by some coefficient, otherwise we would assign the same importance to the current update and the previous one. Usually, we use an alpha of 0.9 to adjust the previous update. Alpha is a hyperparameter, and we can play around with it for better results. 0.9 is the conventional rule of thumb, and this is what I also use. Alright, we considered momentum. In the next lesson, we will look at the learning rate, one of the key hyperparameters of the algorithm. Thanks for watching.